Okay, welcome everyone to the first journal club for this year, 2024. So we have two speakers today, Abisola, Sholeye, and Simon Isaiah. So I'm just going to introduce them before handing over to them, and they're going to present two tools, metabolomic software tools to be used to process and analyze your metabolomics data. So this is aimed towards all the people that hopefully produced some metabolomics data last year in 2023, and now you're sitting with this big mound of data, and the question is, what are you going to do with it? How are you going to analyze it? So there is MetaboAnalyst, which everyone must surely know about it by now, but there are other options, and yeah, Abisola and Simon are going to explain a little bit more about them. So Abisola is a PhD student at Northwest University, and her project is combining both metabolomics and proteomics to look at formalin-fixed paraffin-embedded brain tissue in the case of meningitis cases. So she wants to look to see at the immune response in meningitis cases that died. Obviously they have to die to have collected the tissue, but these are serious cases of infection in the brain. And in the past, we've never actually been able to analyze these FFPE tissue samples. So she is developing a protocol on that to do both metabolomics and proteomics on the same sample. And we look forward to seeing those results coming from her in the near future. And Simon is also doing a PhD at Northwest University, but he's on the other end of the body. He's doing on the urine. So Abisola is on the top in the brain. Simon is doing on the urine of TB meningitis cases, and his task is to try and characterize this neuroinfectious disease based upon the urinary profile using metabolomics. And the ultimate goal of his project is to try and identify a diagnostic signature. So the gold standard for diagnosing meningitis, any form of meningitis, is collecting cerebral spinal fluid, which is a rather invasive method, especially in children and infants. Can be quite dangerous as well to try and get a needle into the spine to collect the CSF. And his project is to try and find a metabolomic signature or diagnostic signature, which we are finding and we're going to be publishing soon, to diagnose this disease based upon the urine. So both of them are in the TB meningitis research fields. Both are in the field of collecting large amounts of data, and they're going to explain to us today, each of them, these new tools that are available to us. So Abisola, I'm going to hand over to you first. And before you start, I just want to, as a disclaimer to everyone, these are not tools that they created. These are tools that they've found online and in the literature, and they're going to try to explain it to you as a tutorial to how to use them. So Abisola, when you are ready, I'm going to hand it over to you.
All right, thank you so much, Graf, for the kind introduction. Now I'd like to welcome everyone to the first Journal Club of the year, and thank you for joining to see what we have to present. Okay, so I'm presenting from this paper. This is the title of the paper, New Software Tools, Databases, and Resources in Metabolomics, Updates from 2020. So this paper came out in 2021. If you have the opportunity, you can have a look at the paper. You can also find other tools on the paper. So today I'll be presenting on VIIME. I call it VIIME, and it stands for Visualization and Integration of Metabolomics Experiments, and it's a path. So what do we know about VIIME? So VIIME is an open source web accessible program that was developed to facilitate the integration of analysis and visualization of metabolomics data from multiple analytical platforms. So if you have data from NMR and also metabolomics data from MS, it could be LCMS, it could be GCMS. What VIIME does is to integrate the data so that you have one whole data from both platforms. So one of the challenges that you may have with metabolomics is you're not able to get all the data that you want from a particular sample from a particular platform. Being in the order of sensitivities, you have the NMR, the GC, and the LCMS. So you generate data from each of these platforms, but really you have to analyze the data separately. There's really no resource or program that integrates all this data. So what VIIME does is it integrates from either your NMR, you can put as many as, I don't know how many data you can actually impute on VIIME, but so far I've seen that you can impute up to 3 data from different platforms. So it uses the human-like orthogonal network layout algorithm and is designed to provide an interactive pathway mapping tool based on the aesthetic principles of the Euler algorithm. So I'm not a bioinformatician, neither am I a statistician. I'm just a biochemist and a researcher. So I'm going to show everyone what I discovered about this platform. And I hope beyond what I'm presenting, you can actually find out some more by playing with this tool. It's an open source. You don't need to subscribe to anything. And there are a lot of things you could play around with on the platform. So what can VIIME do? You get to upload your data to impute, do data imputation, data set. You can see the data set in details. That's after integrating your data from different platforms. You can see everything in detail. You can actually segment to see which one of these data is coming from. You can do data treatments, data analysis, and data visualization, sorry. And also you do the data integration. So to upload your data, one of the things that we may find difficult to do is getting our data in one of these formats. But if you have your data in Excel or CSV, you can actually upload your data on the VIIME platform. And the user interface starts by presenting you with an upload screen, which reports whether you have errors or if there's something you need to do in order to analyze your data before you can start with the data analysis. So here's what it looks like. You have these errors. I'm sure, can you see? I want to put up a pointer. Okay, so you see that if your data is non-numeric, in a column that should have numeric data, it gives you that error. If you are missing a data, it tells you that there's a missing data. And if there's low variance in your group, it tells you that there's no variance. So you can't start the analysis unless you have addressed these errors. So the data imputation. So once you've corrected all your errors, you can start with data imputation. So there's something they call missing completely at random and missing not at random. So it uses these algorithms to impute your missing values. So it uses the random forest algorithm or the k nearest neighbors algorithm for both missing data at random. So in data set details, you have VIIME includes a data set detail. So what you do here, you can name the combined data. You can give it whatever name you want. You can give the group, assign colors to groups, and you can merge your data sets. So this is what it looks like. You give your data source a name. You can describe it in details. If it's FFP sample from NMR and MS. So you get to look at, to describe your data in details here. Then it shows you the correction date and time, the file size, and also your group labels. So you have the group name, the label that you give to the group, and the color that you want to label the group. So there's the data treatment also. I'm sure we're all familiar with this. If we work with metabolomics data mostly, you're familiar with data normalization, transformation, and scaling. So you can also do that on the VIIME platform. And also you can do a PCA plot. We'll do the practical view of what I'm talking about. So you also get to do the univariate analysis, multivariate, volcano plots, heat maps, correlation diagrams. So okay, this is what it looks like. these are the sample groups, and this is what this person is doing, a volcano plot on this sample group. So you can select, you can click on different selections to view these plots, and also you can download each of these plots. And one thing I failed to mention in data integration is you can download the data that has been integrated as one file. So here, down here, you can see that you can download the data. You can also change the color of the metabolites depending on what you want. So this is what a correlation plot looks like. See that each of the nodes represents different metabolites and different colors for different groups. So this could be from an NMR analysis. This could be from an LCMS or GCMS analysis. So you can, each of the groups have different colors. So for the data integration, you can do a mid-level data fusion or multi-block or simple data fusion. So all these things are explained on the platform if you're not really familiar with the names. So it will tell you how it's going to fuse, impute your data or merge your data or integrate your data to make it one. So I'm going to stop here and share my screen showing the VIIME platform. Just give me a few seconds. Okay, so I don't have data from different platforms that I generated myself. So I'm going to use their example data source. So they have data from NMR. They have 3 data sets here. And they also have from MS. So I can import all data. So behind here, you can see that it has already imported data set. So you have the option of viewing the data. So when you view the data, you can do the data transformation. If you want it to be on log 2, log 10, square root, you're just going to play around the data. Also, you have a metabolite box plots here on the right-hand side. I'm sorry?
I don't think it's in. No.
I'm sorry, I can't hear you. Someone is saying something.
Sorry, Abisola, that's been muted.
Okay, thank you so much. So you can also do the transformation using log 2, depending on what you want. If you feel like it's not representing your data accurately, you can play around whichever one. If you want the auto scaling, the Pareto scaling, I think this looks better, right? So you can analyze the table. So what I want to do here is you can also transform your MS data to what you want. I think this looks good as well. Okay. So I can merge the data sources on this side. So like I explained earlier on, if you're not sure of which to use, you can read more by clicking on the question mark right next to the name. And here, data source, I'll just write NMR MS, description, merge data, NMR MS. Then I can do this, click on the data I want to merge. So below here, you see that it's telling me 15 out of 21 samples will be merged. So then you can create. So here it's telling me that 2 of my columns have low variance. You can click on the column and scroll to the right to see the ones that have low variance. So what you can do here is you can mask it so that it takes off that error. Then you can begin with your analysis. So depending on what you want to do, I'll just go through everything. Now all the data is merged. I'm working with the NMR-MS data here. Remember I named it NMR-MS. So here you can do your PCA plots, see what the PCA plot looks like. And do a PLSDA, depending on what you want. Do a box plot, but there's something I really want to highlight here. So within the analysis that you're doing, you can still see what data sets are from what groups. Whether it's from your NMR, you can isolate some, can group based on treatment and all that, on all the things that you have on your data sets comes to life in these pictures. So you can download the data, the merged data. You can also download the pictures as you go. And if there's something you're not sure of or you're not clear on what it does, you can click on the question mark at every point. It explains what it's actually doing. So do also this. Then correlation network, I'm just keeping, but depending on what you want, I feel everyone can have a chance since it's an open source program. You can put in your data and play around anything. You won't break anything, I promise you. So do a heat map. Sorry, is someone saying something?
Sorry,
Okay,
Abby.
so,
You can carry on.
All right. So you can also select data source. If you want to see only from NMR data, you uncheck this. So depending on what you want, you can change the style of your heat map, change it to squares, whichever. And the correlation plot, you can play around this as well. So if you're not sure on what to do there, at every point, that's what I really like about this program. At every point, you get to read about it. And even before you start your analysis, when you click on Analyze table, it tells you everything you can do with the program, and it explains everything. So you can easily click on Analyze, and it goes to the program. So here you can also select specific metabolites. You can put the node labels. You can increase the similarity, correlation, what you want to be strict or less strict. So it's really a program one can play around. So it tells you that the blue nodes are from the NMR data, the yellow nodes are from the MS data. So you can really see the relationship between your metabolites at a glance. So I think, and after that, you can download. So these are the algorithms that we spoke about earlier on. So basically, that's all about VIIME. And there's so much more. If you really want to find out more, you can go on the program and play around with it. All right, that's all from me for now.
Oh, that was perfect, Abisola. Thank you so much.
Thank you.
So that was the first program as an alternative to MetaboAnalyst, and it's quite a nice and nifty program where you can merge data. So people working with large data sets across various platforms, this is something you can look into and just play around with it. So if it's something you like, go into the program and play around with it. We'll have some questions after Simon's presentation, but I'm going to ask Simon to share his screen. He also has a program that he would like to share with us. So Simon, if you can share your screen. There we go. So I'll hand it over to Simon. He has an alternative program which is equally as interesting as Abisola's one. So go for it, Simon.
Okay. Thanks, Prof, for the privilege to present. Can you hear me, please?
Yes.
Okay. Also, thanks everyone for being part of today's meeting. I'm presenting on one of the two program titled Metabolite Autoplotter. Is a paper presented by, that is down here, you can see. Sorry, let me just, okay. I actually saw this program with respect to this paper, and basically Metabolite Autoplotter is an application that also visualize and quantify metabolite data. The primary objective of this is to allow you to plot and also interpret your results. Although with these, you must have done like a pre-process of the data, that is knowing your compounds and having it in an Excel format. Though it depends on the package at which your data is being collected. Yeah, it has 7 steps, although I will explain the next slide. So it's 7 steps basically, and you can see on the web page, there is a detailed manual that allows you to go through and understand how to use this software package. In imputing your data, like I said, different format depending which file the result is being collected. That is trace finder export. There's also compound discoverer and compounds in column and multi-quant, which can be in CSV, sorry, or Excel. And by my right-hand side, you can see how it should be arranged so that there won't be kind of error popping up once you upload your data. The step also with this, once you from my left-hand side from this, you can see that is it data import. When you import your data, once you import it, it gives you like a sample table template at which the software should recognize how it looks like. So you can now download it, then arrange it according to the instruction which the software package has asked you to do, which is very important. Although I will do a demonstration of it using one of our data, which we collected after an experiment that we did. And so here is just part of this sample table, how here you can see file name and the condition of the analysis which you carried out. It tells you the number of replicates and each as well. Each replicate, does it have like an extra extension of replicate as well? So it tells you plotting order, how you want it to be plot. It also give you an a privilege to choose the colors, how you want the graph and other appearance of the table, how you want it to look like in terms of playing with colors here and there. And after doing that, then it tells you the next step what to do, because here the first side, here that's this side, you upload the sample arrangement, how you want the system to recognize it. Then here the second aspect, which is how you the place where you upload your data. Okay, maybe as I do the demonstration, you understand, and the third step, which tells you the PCA, the Volcano plot, correlation analysis, and all that. Yeah, same, and plotting, what to do, how to play around and adjust here and there. It's okay. Before then, let me just quickly end this. Okay, all right. Sorry, can you see my screen, please?
Yes.
Okay.
I see your screen.
And so when you just go to Google, you click on Metabol Autoplotter, and you click here. It takes you to the web page. This is the link that will direct you. Basically, when you click on it, it opens. Yeah, it tells you sounds good. So you just said okay. The first step, I say start. You go to the first step. Here, like I said, how the data is being collected after the experiment depends on which software package the data is being saved. So here I'm using compounds in column. Now when I upload, I have two datas. I have data already that I may just when I put, I'll just show this showing a data of show you how it looks like. Here I put the original. So when I put the original, it gives me an error, and I'll explain the reason. Where are you? Okay. Where is it? Oh, this. Okay. Original trial. And so I put this. I said import. So it shows me now instead of the compound, it's showing me the group, and I'll explain that. But this is not what I wanted, and so on. These are the file name. So I still go back again. The one which I'd worked on. So it gives me the compound, the file name, which actually I just numbered it, and also the datas, which have already collected. So here it tells you sample template, sample table template. So you have to download this, and I don't know. Can you also see it? Can you see the Excel sheet?
No.
Okay, okay. Sorry. Let me share the Excel sheet now. Okay. So can you see it now?
Yes, we can see
Okay.
it now.
So when you download it here, it tells you file name, the condition, and it tells you numbers of replicates. Now I will have to show you what I've done. Okay. Okay. All right. Okay. So the file name actually number them, but do there's a place you keep your original data so that you won't get confused. Just I number them 1 to 76, and of course the condition will have control in my sample. Here I also have 3 cases, 3 additional cases aside the control. Early stage, I named this early stage, severe stage, and also moderate stage. So here where it says replicate, I said these are the number of samples, the number of cases you have in each group. So, and as well, how I want the system, the software to plot when it comes to plotting order, which one should come first, which one should come second, and third, and fourth, and all that. For the color, it's just choice depending. So I said, no, it's fine. The system, I can get the color already. So I'm stop sharing this. Sorry, quickly. Let me okay. All right. Yes. Okay. All right. So after this, you go to the next stage, which I've done that. It tells me the first file containing sample description, how you want it to the system, which he has told you. You upload that, and it tells you the sample itself, which is this one. And so I process now. It tells you process. So you can see it tells me in order, the control, which is the first order, early stage, moderate stage, and severe stage. And the color, he has chosen the color for me. The system actually, the software chooses the color, and the number of cases, I have 44 control, 7 and 11 and all that. So all are just 1, 1. So I asked it to the next. I said, okay, standard, internal standard, more like normalization of it, which it shows. And I said, okay, quality control of it. Okay, now it shows you perhaps if there's anyone falling out of it. So you can decide to go here and say exclude whatsoever you want to exclude out. If you feel it's not looking good, you just pick out and exclude and refresh. So it will redo it. So you said final table, it tells you, okay, this is how it looks. And the color of which, this is how the color it looks. So you can decide to choose whichever. Then you go to the data processing, which is the PCA. And for the PCA, you tell it to run. So it runs the PCA, you can see, and it shows you which one is more. Here you can see it changes the dimension in terms of the PCA. So also you tell the system, the software to extract the loading plot. Sorry, this one. Okay, so you see, it tells you the highest impact. That's the compounds that are highest on this first principal component analysis. So you can also decide to say, okay, let me see the second. Okay, so it shows you the second, which is of different color. You can see it as well. You ask for the third, it does the same thing. Sorry. Okay, and so you can actually play around it this way. You can also go back and say, okay, you adjust, you want a required minimum of sample count. You can say 50. You also do it. It's just to play around, you adjust it, and at the same time, you also check the same way. With volcano plot, which is more interesting, it tells you reference control versus the early stage or severe stage. Let me just pick one. Let me say the early stage, and you ask it to calculate. So it has calculated it, and it tells you the highest when it comes to, based on the p-value threshold. You can try to adjust at the same time to say, okay, I want it at 1. Does it give you any compound? You say, okay, no, you adjust as well. You can see it has reduced the compound that's at p-value 0.01. It is this compound that is highest in the early stage. So you can just play around it. So you can say table. It tells you p-value, which is the one that is significant between the two. You can see as dots showing you here, p-value adjusted, and log and all that. So you can also ask here, it tells you only in control. You can see here, only in control from the total, because I have about 75 of them. And so it tells you highest. You can see in early stage that is unchanged. So there's no much difference with that. In control, you can see here, it shows you. So you can say, okay, p-value distribution. It also tells you. You can still go back and say, okay, with severe case, control versus that, what do you just want to have an idea what's happening? You said you calculate. Okay, it has done that. You can see it tells you the highest versus control. It tells you the numbers of compound. You can see highest in the severe case and not in control. You can see by the side it has changed here in the summary statistics. It tells you 20 of them are highest in the severe case compare. Here you can also change color of the dot here. So you can see, check the table. It tells you the significance of it. Also, this specific compound, there is none for control. So you can see p-value distribution. So you can also go back and say, okay, at 0.01 p-value. So I still have, so you see that 0.01 p-value. These are the compounds. So it shows you the table, significance of it. You can see the compounds and all that. Here, correlation analysis. This is what it shows at this p-value. At you can also check at 1 what happened. This is it. That's total correlation and absolute correlation. You can pay, this is a Spearman correlation. You can also see, you see, it shows you. You just play around it. You can see the pairwise comparison. This is it as well. In all controversies cases and the colors, it shows you. And you can also check the table, each of them. Also, with now the graph here for this compound as citric acid, you set the box plots, the types of plot that you need. If I change it here, you can see here it changes. You can see dot plot, it changes it. You can decide to say violin plot, it gives you. You want to say, okay, I want to show the individual points, it tells you. You can see it shows you. And you can say, okay, no, I don't want this. Truncate in terms of the y-axis. That is, you can see it changes. So it's something to just play around here and there. You can change the name and said, okay, control vice TBM. And so you see it's right there. You can also change the setting here below. You said, okay, I want it to direction of the x-axis. You said, okay, the other way around, depending. You see it changes. It's just playing around and okay, and here as well, you can write the subtitle name below. It tells you, let me just say the TBM. So you see it's written there, you can cancel. If you want it below, you can say the caption to be below. You can say TBM cases. So it shows you down here. So you just play around it and you see it tells you how you want to download how they want the output to look like. You choose whichever way of your choice. And the statistical option also is there. You can say add statistical option. So here you can see multiple comparison. It tells you want to compare in all groups. It gives you the value at the top. That's in t-test parametric testing. You said, okay, with compared to all mean over all, it tells you like that. Also, just okay, against the severe case, control versus this, the difference. You can play around. Medium case, it tells you the comparison between all. So yeah, that's basically you just play around. You can also come here and say, okay, you want it to be in standard error of the mean, not in standard deviation. So also you can say you want the name to be at the bottom or at the top. You can go here, you say you don't want it at all, it erases it. You say, okay, I want it to be at the top. It takes, so you just play around the whole thing. And once you're done, then you generate all plots here. You just download and it gives you. I guess, thank you.
Thank you, Simon. That's a very good tutorial to show step-by-step, very user-friendly software. So I'm going to open the floor up to both Simon and Abisola to questions. So just remind everyone that they didn't create these programs, they didn't write the papers, they just found them online and they are quite useful, as you can see, very user-friendly. So I see Aurelia Williams, please ask your question. We can't hear you, Aurelia. Oh, we still can't hear you, Aurelia. I think something might be up with your mic. Okay, while we wait for Aurelia to try and fix the mic, actually, you're going to type. Are there any other individuals in the audience who would like to ask a question? You can either type it or raise your hand. So please go ahead, question them. They've played around with the software quite a bit. So Aurelia asked, what are some of the main similarities or differences that stand out for you versus metaboanalyst? So who wants to go first? Abishola, compared to metaboanalyst, what are the main similarities and differences that you found stand out?
Okay, I'll start with the differences. One of the major differences that I observed, I don't know if you can merge data from different sources or different platforms on Metabolomics. If you can't, I've not really worked with it so much, but I feel that's one of the difference that I'll say that exists between VIIME and Metabolomics. I think that's the major thing, really.
Okay. Yeah. I think there is a new version out of Metabolomics version 6.0, but as far as I know, you can't do data fusion like you can do in VIIME with Metabolomics. Simon, what did you find the main similarities and differences?
Yeah, I guess with metaboanalysis, with respect to the first of all, the Excel, this one it accepts all format either in Excel or CSV, and also when it comes to the package software, whenever you have data, especially in what format, either in Transfinder or Compound Discoverer, because some of the omics machines depends how the data have been downloaded. And so, but with metaboanalysis, I don't think if you are also have to do other stuff with it first before you'll be able to process and all that.
Yeah, and I think also the autoplotter, metabolite autoplotter, you can have more customizable graphs. So you can play around a lot more versus Metabolomics has only one type of output. Whereas if you want to try and play around with the colors, the formatting, yeah, the autoplotter is quite useful. Any other questions from the audience? So yeah, these are just alternatives then to Metabolomics. They do the same concepts with PCA, volcano plots, but yeah, some have advantages and disadvantages, and some more customizable. So Aurelia, you have your hand up again. I don't know if your yes, your mic is working. Yes.
Thank
And
you.
then Lanika after you.
Okay, so I joined. Thank you, Lanika, that you are here. So I joined a little bit late. I'm not sure if I missed something, but I just want to understand Abisola. So the one that merges the data set, does it take both the NMR and MS data sets and sort of combines it and does like all of the subsequent stuff for both of that data set simultaneously, or are you just simultaneously looking at these two data sets in a window?
Okay, it integrates both data sets from NMR and MS, and also you can work on those data sets individually before merging them. So you can do the transformation, the normalization, anything you want to do on each of the data sets before merging them. So yes, it integrates both data sets.
Yeah, it is data fusion. That's the great term nowadays is trying to fuse data. So we will upload this video on YouTube. So if you missed the beginning part, you can always go through that part again. Launica, you have a question?
Hi, my question links a bit with Aurelia's question. Have you perhaps compared the same data set on this software and on MetaboAnalyst? And for example, does the PCAs look the same, or are there slight differences in the data? Meaning, sorry, with this, specifically the same techniques, is it exactly the same?
Well, I haven't actually used the same data on MetaboAnalyst, but it does the exact same things as MetaboAnalyst. So I really think it's dependent on whatever option you pick. If you're able to pick the same options on MetaboAnalyst and the algorithm it uses, I don't know which one MetaboAnalyst uses. So I think the differences may occur in the different algorithms, but I think basically it should be the same if they have the same algorithms.
So Simon, I know you've done MetaboAnalyst already on your results and you use this program. Were there any differences in the output?
No, not at all. Not much differences, but when it comes to the imaging and all that, it's quite a lot. It's more, it looks a bit, looks good with Metabo Autoplotter, and that's what I found. And it's free as well. You also have access to it. It's free, and so you can just play around it and see for yourself.
That is the great selling point for all of these. They are online, they are free. There's no subscription needed. And you can play around with them like both the presenters say. I think the first one, Abishola, there's more the tutorials as you go step by step with the question marks if you're not certain what you're doing. But you can always go back and read the papers. So both of them have papers written on these platforms. So yeah, these are just alternatives for you guys to play with. So if there aren't any other questions, I'm going to thank our speakers very much for presenting to us these wonderful new toys, these tools that we could use. So I encourage everyone who has metabolomics data to go and try this out. So MetaboAnalyst is not the only platform out there. There are other ones you can use. So you can maybe use MetaboAnalyst if you want to just do the PCAs. Maybe then go to Metabolite Autoplotter to then customize your box plots. So try and combine these different tools together to get the optimal output that you want to get for your publications. And Kamati says, I like the merging of data, hoping to learn more about it. So yes, if you guys are involving MS and NMR or just GCMS and LCMS together, try that program and see how it works. I hope you get success out of it. So with that, thank you, Abisola and Simon. We appreciate your time and efforts.
Thank you, Prof.
Thank you, Prof. Thanks, everyone.
Thank you.